Good day. My name is Brian R. Smith, and I'm currently going for my master's degree in mobile gaming at Sail University. I'm going to take you through a current project that I'm working on called WWI Flying Circus, where you are flying for family, for your country, and for prestige against your friends who you're trying to shoot down. So let me take you through. I'm going to just demonstrate the game for a little bit here. I'm going to share my screen and minimize this. You can see over here, I've got a little window of the game up and running right now. And so there's two different versions of the game that are available. I've got a pass and play where you would make your move on your device, pass it over to your buddy, and they would make their move and they would pass it back and forth. But I also have network play, so you can play against pilots from all over the world across the internet. So let me take you through the pass and play. There's two different airplanes that you're flying. There's this olive green plane that's kind of on the horizon over here, and that is Lord Olive over there. And you're sitting in the cockpit of Baron von Reds with his red cockpitted biplane. And so let me take you through some of the maneuvers available to both the Baron and Lord Olive. This is these two here. This is a wing over to the left and a wing over to the right. And basically you're flying your airplane and wing over, and you're making a 120 degree turn to the left. And this wing over is a 120 degree turn to the right. Now, I don't have all the fancy animations yet. This basically just turns your airplane in space. These two are stall maneuvers with the bar in front of it. And so this would be a left stall. So it'd be stalling the airplane and then turning to the left 60 degrees. And this would be a turn to the right 60 degrees. And this is the Idleman, invented by Max Idleman, which is you fly straight and up into the air, and then you pivot the airplane like this, and so that you're basically turning 180 degrees in a rotation. And right now, again, I'm just rotating your airplane 180 degrees. You can see here another stall maneuver, but in this case, at the end of the stall, you're still going to be moving or facing forward. So basically, in the game mechanics, you're not moving at all in space, and you're still maintaining the same direction. This is forward 1, which is moving 1 unit forward, and forward 2. So this is full throttle, moving the airplane as your biplane forward as fast as you can. Okay, so Baron von Red, he's looking out the front quarter. You can see the propeller over here. He's looking out the front quarter at Lord Olive. So he's going to turn to the left, and Lord Olive is going to maybe not see the red, the Baron von Red there. So he's also going to, let's say he'll do a wing over and then play. So now Lord Olive has both maneuvers available to him, so he can still hold on to the device. So he gets to play. So he's turning to the left, and there's Baron von Red right on his tail, or right behind him there. So Lord Olive instead now he's going to do another wing over to the right. Now Baron von Red, he hasn't seen turn 1 yet, so he's going to play. I don't know if you can hear the machine guns going, but Baron von Red's got a shot here, and you can see the health going down here. Long range shots are -1, medium range are -2, and close range are -4. The Baron's going to move forward, and so he's going to advance upon his enemy, who now did another wing over to the right, another closer shot. So he's got Lord Olive only has 2 hit points left. Baron von Red's going to take another move forward. So now notice with this too, this pass and play, each player is going to have 4 different maneuvers that they do. So Lord Olive gets to see turn 2, so he plays turn 2, gets shot up a little bit more. Then he's going to turn, he's going to plot turn 3, he's going to turn at the Baron von Red, and he's going to play turn 3. And Lord Olive gets shot down. So, but this is pass and play, right? So Baron von Red doesn't know the results of this yet. And so here he's going to play his final turn. And of course, they go right head to head, machine guns blazing, and Baron von Red shoots down Lord Olive. And so you can fly again back to the main menu. So that's the pass and play version of it. And the network play is going to play pretty similar. Again, but you're on the other side, you can be on the other side of the world. So I'll click here, network play, and over in Unity, I will get another, get the editor emulator up and running here. So I've got 2 versions of it playing over here. So I will click network play also. And so we go into the reconnaissance mission where you're now flying over no man's land. And you have the two options. We'll go back to the main menu, or we can search for an enemy. So really this is lobby kind of work, and the searching for enemy is actually establishing a room. And so this is still searching for the airplane. Over here, search for enemy now finds that there's somebody that has already created a room. So this player over here already created the room, and now we're ready to dogfight, right? There's your arch enemy dogfight. So now you're sitting in the cockpit for Lord Olive, and this aircraft over here is going to be in the cockpit for Baron von Red. Plays similar kind of way. It's just as fast as you can make your moves on either side here, and play and play. So I'm going to go forward with Lord Olive here. And so it just, I'm sending the same moves over the network. And again, just as fast as you can play. So there's the game. Really, it's just the start of it. There's a lot more to be done. Well, let me take you through some of the code involved in making this kind of game work. So I'm going to stop that, and take you through here. So I've got one of the feedback, some of the feedback that I got from my professor Penny was that I was putting too many things into just one big file. So most of my everything is in this move lerp one C# program. So I'm starting to, as I'm adding new features into the game, I'm starting to put them into different files. So good advice, and I'm trying to break things up and so I can test easier for these individual files, get them rock solid, and then they can just plug them in and use them as a rock solid kind of component. So some of the things you can do in Unity are just amazingly fantastic. The look at objects, so you're sitting in your cockpit, basically there's a camera sitting in your cockpit, and look how easy it is to just always have that camera sitting in the cockpit, always looking at the enemy as you're flying around this three-dimensional space on one plane. There's no climbing or diving in this game. So there's some things that are just really amazingly easy. From an audio point of view, this took a little while for me to get working. The audio in Unity is three-dimensional. And so really you have listeners, and you've got audio sources. And so I had to have the machine guns be an audio source on the two different aircraft. And I had to have the listeners be with the camera that you're sitting in the cockpit, and with distance and attenuation of the sound. So it's more than just the programming here. Looks very simple, of course, because really all I'm doing here is just setting up the audio sources. But it's in Unity there's a lot more drag and drop, and it's there's more things going on in the move lerp where I'm actually evoking the audio sources, and I'll take you through that code too. For the vibration, this took a little extra work. I did find some fairly good working content on the internet that I'm citing there, but I did have to make some modifications to it. Some minor things for me. I wanted to change things around, but the major thing was if I'm compiling for a standalone a standalone system like a Macintosh, Windows, or Linux or Unix, I had to not even have this so that the compiler would see it. So I'm using a statement saying if it's not Unity standalone, then don't even compile with this, because I was getting all sorts of bad errors if that was there, if it was being generated for Windows or for Macintosh. So just a few bits of modification, but otherwise this gives me the ability to, on a handheld device, which wasn't demonstrated here, but on a handheld device, you would actually, when you're getting shot, you would actually feel the vibration. If it's at close range, it'll vibrate 3 times in your hand, medium range 2 times, long range will be vibrating once in your hand to kind of give you an indication of the amount of damage that you're receiving. For the lobby manager, this is what handles the establishment of the network communications. And again, I'm citing a source here. I basically watched a YouTube channel to kind of see how to do this. And then with the lobby manager, there's things that you do at the start just to kind of set up the environment, but really it is connecting to the master, And then when you say, hey, I want to find the enemy aircraft, really what you're doing is you're looking for a room. If there's no rooms available, then you create a room and join that room. And if there is a room available, you join that room, and then we're ready for a dogfight. And so this logic has been pretty much proofed for both sunny day and rainy day. I probably have a little bit more work to be done there. And one of the things that I did that I had to change as I was coding this is I needed to create another mini state before, once you clicked on dogfight, if the other player didn't click on dogfight and you sent your first maneuver, that maneuver was lost. And so I had to add a little mini state to synchronize the two players to make sure that they were ready for the dogfight, and then they're ready to play. Okay, so this is where the lion's share of the work is being done in the WWI Flying Circus. You can say I've got my, I am using some assets and some citations there. I've got my to-do list, a change log, and these are the user interface elements and audio source elements that are associated with different game objects. And then Unity is really nice because it allows you to drag and drop these things, and now you have an object that you can reference in your code. So very useful, very powerful mechanism for doing everything from turning on and off the different canvases as I'm changing states, to being able to handle the buttons that are being pressed, and also to arrange the different audio sources so that the machine gun fire is coming from the other airplane rather than coming from you. So lots of variables, of course. This is a program, if nothing else. The start is fairly simple, just basically establishing some variables and all that. And I do have a routine that resets the game, whether it's just at the beginning and the start here, or anytime that you replay the game, it automatically resets everything and clears up all the variables so that we're all ready to go. Now the update, you always want to try to keep the update as clean as possible. And really this code down here is the only thing that's really executing repetitively while I'm updating the screen. So while while you're waiting for a plot, there's nothing really that's going on in terms of the update. The propeller spinning is just animation, so it's not really updating the positions of the different aircraft. But when you do say, hey, I want to see that move, I want to play that move, this is the code that actually moves the airplanes through space using basically a linear percentage of the amount of time per turn thing. So I'm just physically actually moving the airplanes through space for each frame of that's being displayed to the user. And so this is the only thing that's really executing repetitively until I get to the point where the time elapsed is greater than the amount of time. And currently it's 2-second turns. And when that happens, then we know we're in the end of this movement. And so here's where I would jump out of this and start doing some extra work about saving the transformations. And so what I do with this is, because it's asynchronously plotting, I save the transformations, both the starting position and the ending position, so that no matter where you are in the turn, you always have that information about the other guy. And I have some tests to say, can I play this turn? Can I test or plot that next turn? So by keeping all that information, I can always go back and forward, because with the pass and play, as you saw, it actually is you're doing these 2 plots and 2 plays, but it's over the course of 3 turns. It's just amazing that you can do that. But anyway, you have to keep track of a lot of information, and so this is what I'm doing here. It's a little bit of spaghetti code, I would say. So I created the pass and play first, proved that I could do this kind of asynchronous plot and simultaneous play kind of operation. And then what I did is I added the network game, and I didn't anticipate everything I needed in the pass and play for the networking. And so I've got a lot of code that's, oh, if it's network, then do it this way. Oh, if it's pass and play, do it this way. So this is some of the spaghetti code that, when I have the time, I'd like to refactor and improve so that to minimize the 2 different code paths through minimize number of code paths through this movelerp1 C# program. So anyway, after the based upon whether it's the two different network games, we take a look at the shooting that's going on, calculating the damage, and then we need to see if somebody has won the game, and if there is, then we call win-lose. Otherwise, we're ready to pass. If it is this win-lose, we're ready to pass it over to the other player. And no winner yet, we go back to plotting. So right after playing, if there's no winner, you always go back to plotting. So it's plot play is the basic mechanism for this. And then we say, hey, we're done with updating. So then this loop will then work as efficiently as possible. And then too, I do have a reset for the transforms to get them back into the starting position. So really, like I mentioned, that the update, fairly efficient in what it does. I've just added a to-do list on here. What I'd like to, if I've got the time in the future, is these positions, I can calculate these ahead of time and have them available in arrays, so it's even more efficient as it's going through here. But we'll have to see about performance over time. So you'll start seeing some of the messiness in terms of spaghetti code. So I've got this set destination, which is where this maneuver string, which is just a 2-character string, is being passed back and forth, usually over the remote procedure call for the network. And then depending upon whether it's a network game or not, then I will set the destination for the net. And you can see here, this is a little bit spaghetti because of that. And then also too, I've got a set destination, the pass and play, and it's doing a lot in some of the different kinds of things. You hear that logic is that same spaghetti code right there. So again, in the future, what I want to do is have the code such that when you even pass and play, so you're physically on the same device, I want to send over a kind of a stub network the character codes for the maneuvers to the other side of the program, so that no matter if it's pass and play or going over the network, the logic can stay the same. So I don't have to have this spaghetti code. And you can see here, this plot maneuver code is the same also. And so that's bad programming. I apologize for it, but it was indeed kind of this iterative kind of solutioning. So just pointing out, there are always opportunities for making improvements. So just some simple tests here. Is the turn playable? Here's the, I'm using the Photon plugin for networking, the PUN, so the Photon Unity Networking 2 version of that. And I really only have 3 RPCs that I'm doing, the remote procedure calls. And so this is the main one where I'm pushing the 2-character maneuver over to the other device, and the other device then does all the logic themselves. I needed to add I have surrendered. I didn't demonstrate it, I should have, but there's a surrender button up in the top, and you say, hey, I give up, and that interrupts the this plot play back and forth. It interrupts that, and so I needed a special event or message to go across to the other player to say, hey, I've surrendered. And then also too, this is that, I mentioned that in the networking, before you click if you click the dogfight button, before the other guy gets the chance to click the dogfight button and you select a maneuver, I needed to synchronize both systems. So I did that with a RPC call there too, to say, hey, I'm ready to dogfight. And then these actions are really basically button handling. So it's you've done some button on the in the user interface, and so it's action this. Here's action in the lobby, action play, action I want to start pass and play. I've clicked I want to start network play. So it's the different kinds of actions that are happening. You saw the pass, win or lose, which is, hey, I've won the game or I have lost the game, and now I have to have a state in which I hold off and have to ask you to pass it to the other user, or else they're going to see the death of you right away. So as I had to interrupt again this plot play by inserting a small little state. The win-lose processing, action surrender, again, is kind of that another pause in the state machine. And then calculate the shot damage. So here's where do some interesting things with this. You have to make sure that the enemy airplane is facing the other aircraft and it's within a certain distance of that aircraft. And then here's where I will do the vibrate shot. And so this distance one is close range. And so this is the most vibration that goes on. Here's the machine gun sound goes off. Keep track of the turn information, and then some debugging. And so then the same kind of mathematics for the medium ranged and the same kind of mathematics for the long range. So a lot of the action happens in this calculate the shot damage. And there's the machine gun sound, playing the audio files, vibrate shot. You can see here, last I did was I compiled this for the Macintosh, and so really nothing happens in this in terms of vibration. And so I had to deactivate all the different kinds of calls to make sure that I wasn't compiling. I think Mr. Unity should have been able to handle that himself inside of its code, but it wasn't. And so I had to deactivate it myself. Maybe someday I can take that out of there. But for right now, I guess it's an advantage too, is that it's not going to even evoke the calls. So you'll save some CPU by not even doing it if it's not necessary. I got a player status that I update in the user interface. And then I'm calling this state, and it's sort of a state machine, but it's not a state machine. I'm pretending it's a state machine, but basically, given the new state that I want to get to, I'm basically turning on and off the different canvases, and then from time to time updating the status message that is being displayed to the user. So basically, just moving the user interface from state to state, although the program itself is operating based upon those states too. So another thing with these, I've got two different cameras, and so I have to move the cameras. You're sitting in Baron von Red's cockpit. Now you're in Lord Olive's cockpit, but also too I have to swap not only the cameras, but I also have to swap the listeners. And so this code handles that for me. And then, as I mentioned, here's that reset game. And wow, nothing like 1,000 lines of C# coding to have a fun game that you can play. So that's kind of a tour of the code, a tour of the game. There's all the Unity bits and pieces. I don't want to really go through that too much, but I got the 2 biplanes. These are just free assets, from the internet. So basically a texture for the ground that you can see even the corner here, I didn't stretch it all the way out to the horizon because it makes it look funny. So I've got to get a new texture for that. A skybox. Lobby manager is where the C# code for the lobby exists. And then these are the different canvases that I'm using for the user interface that you saw that I make them active or I deactivate them. And then inside of, for example, the canvas plot red, there are the buttons. And you can see here L2, if we look all the way down here, you can see this will call move lerp set destination with the character string L2. So these are the 2 character codes that are being passed over the network, or what I want to do in the future is pass those codes even within the program for the pass and play. So that's the grand tour. The final thing I wanted to just cover is just some questions about this project and related to the class. One of them is what learned material, did the learned material meet the expectations for this class? And I think the answer is yes. Basically, for this class, Unity is new for me. I've never programmed in C#, although if you've programmed in 30 different languages, C# is not that different than the other languages. The whole Unity and objects and working with that was brand new for me. It was wonderful to see the pass and play concept work. And then using the photon with the networking. I've done a lot of networking in the past, but of course it's always new and different to work with that. So that took me quite a bit of time. Vibration was new. Um, the sound, again, as I mentioned, as I was going through that, I've done sound in Android, and it's, the Android is trivial, but here it was a lot more involved because it's this three-dimensional sound, and as I explained before too. So lots of things, just everything that I did, honestly, everything that I did was brand new. So yes, the material we learned was definitely met my expectations. So the topic for the class, was it useful for the future? And the topic earlier was on the testable code. And yes, that really is useful for me. I was working for a large multinational corporation. I was a programmer for only the first 5 years. And after that, I did other things. And towards the end, I was a manager, but never really involved with pure play development at that time. So a lot of the modern kind of testing, of course, we did testing back in the 1980s, but a lot of the modern testing and testing for object-oriented things, I don't know. And so I'm really looking forward to learning that, doing that. And I am a test by the seat of my pants kind of individual, but I know I need to have some discipline with that. So this topic is going to be very useful. Testing is going to be very useful for me into the future and even today. And then the question is about the framework. This framework, I did Unity. The next framework I'm going to be using is the Android Studio. Did it meet my expectations? And yes, largely it met, if not exceeded my expectations. There were a lot of quirky things that you have to kind of work your way through. I'm not convinced I am doing everything in the most optimal way. For example, the maneuvers I hacked in C# code, and I'm playing around with animation and timeline to see if I can use cutscenes to have that be more complex and a lot easier. So that's why there's only a finite number of maneuvers, is because as I get into more complex maneuvers like barrel rolls and things like that, I don't want to have to hack each individual frame in C#. I want to be able to rely upon some of the more powerful tools in Unity. So yes, it's met my expectations. Again, quirky in some things you have to kind of work around, and they do it in a particular way that's maybe not the way that Android Development Studio is doing, but outrageously powerful, just like the concept of having a camera follow a target object. It's so easy, and you think like, oh, it's gonna take me a couple hours to get this working. You cruise around the internet and you find a YouTube video, you watch it and you go like, wow, that's easy. And creating the objects, dragging a few things, a little bit of code, and 10 minutes later it's working. And it's just, some of it is just spectacular. And yes, I'm doing this specifically for my capstone project. So I know you had the estimate of like 40 hours for this project. I've probably been programming, probably closer to 80 hours. 80 hours would be, 8 hours a week, 5 days a week. I have been programming probably 10 hours a day, including some weekend work. And so I've been putting a lot of work into this, but mindful, this was all brand new to me. So again, C#, Unity, working with these kinds of environments, it's all brand new. And so I wasn't the most efficient. And so I'm learning as I'm going, and I'm just hacking away as best as I can, which is, so the answer is yes, this will be useful for my capstone. Not convinced yet if this is the code that I'm going to keep, that I should basically refactor, or if I'm going to just start from scratch and knowing that it works, start doing it in a better way. But yes, the framework met my expectations, and I will be using this for my capstone. So with that, thank you very much for listening. I think I got a little bit verbose there, but if you have any questions, feel free to reach out. So again, thank you.